A conductor 36 inches long carries a current of 1,500 amps. What is the flux density at a point 12 inches from the wire? And A, 12 inches from one end toward the other end. B, directly opposite the center of the conductor, and C, directly opposite one end of the conductor. For this problem, we are going to use the formula flux density is equal to I over 10 times R multiplied by sine theta 1 minus sine theta 2, where BP is equal to flux density in Gauss. I is current in amp, and R is the perpendicular distance between point P and the conductor in centimeters. And theta 1 and theta 2 are angles measured as indicated. Note particularly that theta 1 and theta 2 are given opposite signs, positive and negative, when the angles are on opposite sides of a normal line from point P to the conductor. For letter A, we have 12 inches from the wire and 12 inches from one end toward the other end. So this makes our point P. So if this is 12 inches, this is also 12 inches. Same goes on this side. Now if the length of the conductor is 36 inches long, and this is 12, the remaining part must be 24 inches. Now let's draw lines toward each of both ends to form two right triangles. With this, we can solve for theta 1 and theta 2. For theta 1, since we are looking for the angle, we are going to use the reverse tangent of opposite over the adjacent sides. So we have reverse tangent multiplied by 12 over 12, which is equal to 45 degrees. Substitute to the formula sine theta 1 is 0.707. Now for negative theta 2, same formula, reverse tangent times 24 over 12. And this is equal to negative 63.5. Therefore, sine theta 2 is equal to negative 0.895. Substituting this in our formula, I is equal to 1,500 amps over 10 times R is equal to 12 inches, but we have to convert this into centimeters. That's why we multiply it to 2.54 times 0.707 plus, this is now a plus sign since negative times negative is positive, 0.895, and this is equal to 7.88 Gauss. For letter B, the point is 12 inches directly opposite the center of the conductor. Therefore, both sides are same equal lengths of 18 inches. For theta 1, same formula with letter A. And this will yield to 56.3 degrees. Substitute to sine theta will give us 0.832. Since both sides are basically congruent, theta 2 will produce the same values but negative. Plugging these into our formula, and this will give us 8.19 Gauss. Lastly, for letter C, the point is 12 inches directly opposite one end of the conductor. This is theta 1, and since we only have formed one right triangle, theta 2 is 0. Solving for theta using the formula, we will get 71.6 degrees. And substitute it to sine theta, we'll get 0.949. Now plugging this into our formula of flux density, we have 4.67 Gauss as our answer.